Very welcome to this Software Center lunch seminar. My name is Carlson from Mälardalen University, and today I will give a kind of general overview and a bit of recent results in the work we have done in Software Center on development artifact consistency. So, to start with, as an introduction, when we talk about artifact consistency, what do we mean and why do we believe that this is interesting? So artifacts, the type of artifacts we talk about are, in addition to kind of code being the main result and the main deliverable of the development process, there's also a lot of other artifacts involved or produced and needed. So we have requirements, we have architectural models, we might have design models at kind of lower granularity, we have test suite, we have different types of documentation for internal or external use, and we might have configuration files, etc. And of course, some of these artifacts are only kind of one-time use. It's something that needed to capture some initial ideas or to capture something very kind of temporary. But others are kind of needed throughout the development and also the operation of the system. So it might be that we need some artifacts in order to generate some other artifacts, either automatically or manually. It might be that some of these artifacts are needed for assessment of, for example, safety or security properties. Or it might be that during maintenance, if not during the development, but during maintenance, we need these artifacts, and we need them to stay reasonably consistent with each other in order to be of use. And it has been noticed that as long as we have these very kind of the traditional very long development cycles with activities in different kind of phases, this consistency is often handled by kind of making one version of the artifact and then freezing that while we work on other artifacts and other phases. We might have a kind of a version of the design document that has been kind of improved, and then it's frozen, and then we work on the implementation based on this frozen version, and then any kind of changes or any improvements we want to do on this artifact will have to wait until the next iteration. And this works fine as long as we have these long cycles, but with the kind of desire to try to shorten the development cycles, this need for kind of consistency and the need to manage consistency becomes more important and also harder to handle. And in some of our previous research, this lack of, in that case, model synchronization, but the general artifact synchronization has been identified as a key impediment for combining more model-based and model-driven development and more continuous integration, more kind of continuous agile ways of working. So having this kind of synchronization, these possibilities to synchronize and kind of ensure consistency between artifacts is indeed important. But the question is how much consistency is enough and how much consistency is maybe too much consistency. And we can say from the start that having complete consistency at all times between all artifacts is of course not feasible and is not really desirable as well. So of course during the kind of the daily work with an artifact, we don't expect it to be even internally consistent all the time. We don't want kind of just as when working with code, we don't want kind of compiler errors every time we make small changes. We want to be able to have this kind of inconsistencies for some time, and that of course holds for kind of artifacts in relation to other artifacts. When working on them, we don't necessarily want them to be consistent. But looking at kind of different artifacts, we also have artifacts that are at different level of abstractions, meaning that we don't want them to be complete. We want them to represent slightly different kind of abstraction levels of the. So even if they model the same product or aspects of the same product, we don't want them to be completely consistent. So we might have much more details in one artifacts, and we want them to stay kind of generally consistent, but we don't want them to. We don't want to enforce too kind of strict levels of consistency. And we also have cases where artifacts might represent slightly different version of the products. So if we imagine a case where we start from a kind of architectural description model, and then we start implementing, and while implementing, we also work on improving the architecture for the next version or for the next interface. We might have at that point inconsistency, both because we haven't yet fully implemented the previous architecture, and also because we have now made kind of new changes at the architecture level that we don't really expect to be mirrored in the implementation yet. So kind of finding the right level of consistency between the different artifacts, and also kind of balancing the benefits of having a very strong consistency with the added overhead, because of course kind of enforcing or kind of achieving this high level of consistency also come with some overhead. So finding the sweet spot between balancing these. And the very, very high level kind of description of what we envision is a very lightweight approach for consistency management and synchronization between artifacts, with a low overhead for managing these correspondence links. So for managing what the different concepts in different artifacts should indeed be consistent. So trying to have a very low overhead for managing those, so that we don't add more overhead than we gain. And the idea would be to try to include consistency checks where appropriate in the regular CI pipeline, and automating this to as large an extent as possible. And also, rather than enforcing consistency, rather the aim is to warn and to make developers aware when they are making some changes in one artifact that might affect the consistency with some other artifacts. And it might be, if it's on purpose, if it's kind of known, that's not a problem, but making sure that there are no inconsistencies introduced when it's not really meant to. And when possible, if it's possible to also, in addition to kind of detecting and warning about inconsistency, if it's possible to also help kind of quickly resolve them in typical cases. So this is not something aiming to do automatically, but having some support for kind of typical ways to resolve them. And this is a well-studied problem, so we are definitely not the first ones looking into this. So from academia, there's a long list of solution proposed, especially if we look at the kind of model-based domain. There's a lot of work on quite heavyweight solutions for example, bidirectional transformations, where we can kind of make very hard links between multiple model artifacts, ensuring that any changes that we make can be directly and automatically kind of transformed and implemented in the other artifacts. There are rule-based consistency checks and these general constraint languages that can be used to define consistency and synchronization rules. And we have the area of co-evolution, either between multiple models or between the kind of model and the meta model. So we can handle also changes in the languages and underlying meta models, and we can kind of co-evolve the model together with that. But we can also see that most of these approaches are not very well aligned with industrial practices. So looking at kind of reviews of this work, we can see that they are rarely evaluated in industry. And in many cases, they're kind of suggested as a theoretical solution, not really integrated in existing tools. And of course, that's really challenging, and especially since most of these involve artifacts maybe developed in different tools. So you would need to have solutions that kind of span multiple third-party tools. And for these complex solutions or kind of approaches, it's often unclear this balance between. So although they kind of solve the problem, it's often unclear what new costs they introduced and what efforts would be needed to also keep these new kind of artifacts. For example, the correspondent links in order to keep them consistent. So the main kind of result that I will describe today is the result of research that we have done during this sprint in Software Center and starting in the previous one, where we wanted to investigate real industrial consistency challenges, but also identify the current and the desired future state of consistency management in these companies. So what we did is, from the collaborations we have and from some additional companies, we collected 13, let's say, consistency relevant scenarios from 9 companies, from a number of different domains, so automotive, avionics, consumer electronics, industry automation, railway, and software tools. And of course, this is not kind of representative of all industries, and we're not really claiming that these kind of reflect the complete industrial state of practice, of course. But at least it gives some indications of some problems that do exist, and the kind of state of art and the state of practice for addressing them in these companies. So from these 13 scenarios, we had 4 that were related to the kind of relation between a system or architectural model and implementation. We have 3 that had the similar kind of correspondence between a design model at lower level and implementation. And 3 of them had to do with consistency between the software design model and the test cases. And then we had 3 more that involved more than 2 artifacts, including some of these from the other scenarios, but also some of them involving the relation between kind of system and software models at different levels of granularity, and between implementation and test directly. So kind of categorizing these and looking into, and also through interviews and through workshops with these companies, the first question that we wanted to investigate was, what are the actual kind of problems encountered related to consistency in these? So in some of the scenarios, even though there is kind of need for consistency, they reported that they don't really face any, or they haven't really encountered any particular consistency problems. And in some cases, it's because models are kind of used initially, or they are kind of mostly used to communicate initial ideas, and then it's generally agreed that they will not, it's kind of generally understood that they will not remain consistent, and they are no longer a kind of source of up-to-date information. So consistency is not really a big deal. And then we had these kind of 2 categories where in 6 of the scenarios, we would say that consistency is kind of needed for correctness. So, and this particularly has to do with when there were tests involved. So when we have kind of evolution of other models, or we add model variants, the tests, if kind of they become inconsistent, we have tests that are outdated with respect to the models, and we need to be able to kind of detect this and to ensure that the tests are consistent with the the final model of the final version of the models. And also in cases where the kind of consistencies between implementation and higher level architectural specification, it was reported that there are kind of problems, especially when at a late stage you discover implementation violations of the interfaces defined in the architectural specification. And then we had some scenarios where consistency is more seen as the problems reported were more seen as a maintainability issues. So even though the implementation is kind of correct and so it's not a problem, but it causes problems in the maintenance because the model is no longer a reliable representation, and the reported miscommunication, then a kind of unnecessarily steep learning curve for new people to become productive. And there's also one scenario where they explicitly want to be able to keep editing the kind of system description in multiple notations. So if they become inconsistent, it's no longer possible to do this. So those were the kind of overall consistency problems reported. And looking at the consistency management kind of mechanisms currently in place when it comes to kind of identifying and establishing these correspondence links between different artifacts. In quite many of the scenarios, they reported that there is explicit links between the artifacts, and these were especially in the cases involving test cases. And many of them rely not on explicit link, but kind of implicit links, just caused by naming conventions. So either having kind of equivalency, saying that there should be some concepts in the model should be equivalent to some concepts in the code, for example, or through similarities, although there's not a kind of complete equivalence, but there's still kind of naming similarities that could be used for this. And when it comes to consistency checking, in most cases they were manual and on demand. So, for example, during code reviews, checking consistency is kind of done as part of those processes. We also had some cases where there is kind of automatic consistency checking that are automatically triggered, and in some cases they reported that although consistency is kind of needed, there is no consistency checking in place other than kind of very informal. And when it comes to inconsistency repairs, most of them are either manually or there is no real support for repairs. And there was only one scenario where there was some automated repair implemented. And looking at the desired consistency management, so what is the kind of desired state of consistency management in the future? There was a very limited ambition when it comes to improving the traceability kind of between artifacts, and also for most companies, automated repairs were not seen as feasible because there was a too large conceptual gap between the artifacts to be synchronized. But a majority of the companies reported that they wanted to adopt automated consistency checks or more automated consistency checks. And there was a kind of desire to go towards more continuous model-based development in these cases, where you have kind of changes in the model continuously validated as kind of part of the continuous integration pipeline, to avoid this propagation of inconsistencies. So you have some problems that are kind of propagated to other artifacts and causing more problems later on. So in addition to this investigation in the kind of the industrial current practices. We have a number of ongoing research, research work together with the software center companies on some more specific topics in this area. So the first of them is a work on how to identify manual changes to generated code. So in this case, we have a low-level design model with generated PLC code that's manually edited during the deployment of the code. And the task is to identify these manual changes, and in the next step to be able to back propagate these changes to the design models in order to restore the consistency between these two artifacts. The second one is on the topic of just establishing the correspondence link. So as the first step before the actual consistency checks, to just find out and to establish what are the correspondence links between these. And in this case, it's between the kind of implementation code in C and architectural models in SysML, and covering mostly structure, but also some behavioral aspects, since the SysML models includes also state charts. So we can to some extent cover behavioral aspects as well. And the third one is detecting inconsistencies for artifacts with informal semantics. So when we don't have a very kind of formal semantics and a kind of formal model to rely on. And the approach here is to do this in two steps. So to first formulate conceptual consistency rules, kind of the important concepts and how they should be consistent. And then in the next step to map these conceptual entities to concrete representation. And the fourth one, which is currently a bit on hold, but we have looked into how to manage consistency when we have models that represent at the same time multiple variants and versions of the concrete products, where we need to have consistency not with the whole model, but with a kind of selected subset of it. And it's now 12:26. So with that concludes this short overview of our work on consistency between artifacts. So if this is something that sounds interesting, please contact me or Robert, Antonio, or Federico, who are also part of this project.